guys, so we are continuing our software series, and in the previous video we watched the Fritzing software package, and now we're moving on to iCircuit. This is one of my favorites because it helps me visualize and see what's actually going on in the circuit that I have built. It'll help me see if I am probably damaging or if I even burnt something. I really like this package, and I hope you guys enjoy it as much as I do. Okay. Alright, so this is basically what it's going to look like, but let's go ahead and actually start from a fresh new file. So this is what you get when you click on new, and you get a blank canvas pretty much, and here are the main tools you're going to be using. So this is where all the components are. So let's go ahead and drag a DC source. So this is a voltage source, and in this case it's set up for 5 volts, and you can click on the component and see its details over here, electrical parameters, and you can even name them and change the values of those that are modifiable. So let's go ahead and bring in, let's see, we're going to need a LED if we're going to light something up, so let's drag this over here, and again you can click on that component and it'll tell you what its forward voltage is, and it'll tell you current and voltage whenever current is flowing through that LED in a circuit. So let's actually complete that circuit. We just click and drag from the terminals of the components, and it'll try to find the best path for that wire. In this case, this is what it chose to be the shortest path, and as you can see here, if we click on the LED and we move over to, well, first of all, it's showing you the current flow. Even though it is traditional current flow, it's still useful. But if you look over here at the parameter, the current actually says 1 gigaamp, which is obviously way too much for that LED. That LED is pretty much burnt. So well, this is very useful because you can even graph the current through a component and down here in the oscilloscope. Okay, so, well, that's great. So let's actually protect our LED. So let's see if we can find a resistor over here and drop it onto the canvas. Now for rotating, this is what you do. So if you try to drag the terminal or the leg on one of these components, it'll try to draw a wire for you. So what we do is we actually select the component, and then when it's selected, we drag one of its terminals, and then we can rotate it. And as in the case of the resistor, you just drop it in, and there it is. It's working. So it's a 1 kilo ohm resistor. You can see right there. And now you can see the current actually dropped to a more reasonable value. So it's 3.2 milliamps, which is well within the tolerance range for an LED. So this is a much more reasonable circuit. And if you again click on the component, you can change its values. You can see currents, voltages, voltage drop, etc. Okay, so all right, let's make this circuit a little bit more useful. So let me see if I can find what I'm looking for here. There's a lot of components here, as you can see. Oh, here it is, the switch. Okay, so we're going to drop that in there, and again select it, grab one of the terminals, and then just drag. In this case, I've actually made the component huge, so that's not actually wires coming out of it. It's actually just stretched out so that it connects to the existing wire. So you can select it and close it from its open position, and you can select the LED, and you can see obviously we have the same amount of crazy current running through this thing again. Let's actually open that. We can change it in this case because the switch can also be momentary. Just leave it as it is. And okay, so what other neat stuff can we do with this? Well, one of the cool things about iCircuit, one of the reasons why I love it so much, is because you can learn about components and learn about how they work. In the case of transistors, for example, you can actually understand just by trial and error and by visually seeing what is coming out of each terminal. As you can see here, the LED is not lighting up. So what we want is, number one, we want to actually understand enough about the components to make sure that we know how they work. But we can, through trial and error and just like connecting things here and there, we can actually prove to ourselves or understand how it is that a component actually works. So in this case, now the LED is actually getting the 2.6 milliamps. which is great. We've activated the base, and current is flowing through the collector emitter. And we can study a lot of the parameters that the components have. And we can connect them in any which way, and we don't have to worry about burning ourselves or setting things on fire in our lab. So that's what's really cool about this software. You can even use it to understand the working principle behind a lot of these components that are going to be really important in electronic projects in the future. So, all right, let's see what else we can do in iCircuit. So this is one of the basic circuits that we had: a power source, a switch, and a resistor. And we all know what happens. If we close the switch, current flows. We see the current flowing in the animation, but we also get this oscilloscope at the bottom. So let's go ahead and select these components, and let's actually build something that is neater to see in an oscilloscope. So here's our 5-volt source and our resistor, and once again, this is where you bring in the components. Here's our switch. This is how you rotate them. All right. Switch is not complete because the circuit is not complete because the switch is still open. And I actually want to fix this and take the time to show you that you can also see current flow in wire traces. So not just by selecting a component, you can actually select a piece of wire and see exactly what's going on. We got 5 volts coming out of the source. In this wire stretch, there's no amperage. There's just a potential difference of 5 volts across this switch. Again, 5-volt difference right there. Across this resistor, there's nothing going through it. And let's go ahead and set an example here of changing values. So let's see what happens. If we close this switch, we can now see the animation, and we can select this wire trace right here, and we can see that 5 milliamps is actually flowing through this piece of wire now. And if we go to the component, we can see those same 5 milliamps running through the resistor. There they are. And the 5-volt difference right before the resistor. But after the resistor, it is now 0 volts. And so you can use this to very handily prove to yourself and understand or analyze circuits in series and parallel using Ohm's law. This is perfect for practicing and visually confirming what it is that you are designing in a circuit before you actually build the circuit. So let's go ahead and look at some other examples. Okay, so we've seen this example, and this is simply current running through the circuit and lighting up a LED. Great. Let's analyze one of those circuits and introduce a new component and see how it works. Okay, so this we know how it works. This is great. LED lights up. You can see it's orange. We've seen how to visualize amperage and voltage differentials and voltage drops, for example, across this resistor, a 3.2 voltage drop. Now let's actually bring in a new component and understand how that works. And there is that 1.73 volts left over after the resistor. Okay. And there is the LED with the 1.73 volts left over after the resistor. Alright, so here we have a visual oscilloscope representation of the current running through the LED. It's a fixed 3.27 milliamps right there. If we change its value to 100 ohms instead of 1000 ohms, you can see the current running through the LED is much greater, and it's actually now lit up in red, which means it's probably burning up. If we drop, or if we increase the resistance to 220 from 100, we can see that the current actually dropped a little bit because we have a greater resistance. When we change it to 10, that current jumps back up. Our LED probably starts to burn. So this is one of the main advantages of iCircuit. You can actually test, move around stuff, and see how it is that current is actually flowing and how it is affected and how voltage is affected from one terminal or from one node to the next. So let's just finish the circuit and leave it with a open switch, and let's switch over to this circuit, which is basically two circuits in one. So you got that one on the left side, which is the regular 5-volt source with the switch, and you got the one on the right, which has the LED in the cap. When we select components, we can view their parameters and their values. If we want to graph something on the oscilloscope, we just click on it over here in this window. So right now, there's very little current running because that capacitor has been on for a while. Let's actually go ahead and close the circuit. And now current is going to run through this capacitor, and the charge on the capacitor is actually going to jump up. So right now it is at 9, and it jumps up to 125, which is the green line on the oscilloscope at the bottom. And if we want to open that circuit, the capacitor is now powering the LED, and you can see the capacitor charge dropping, which is the green Q line, and you can see the current running up, the current through the capacitor. And just like that, we can mess around with it and just keep playing, charging the capacitor, discharging the capacitor, and understanding what is happening with charge, with current, and voltage difference across the different nodes. All right, so this is one of the great and most useful features of iCircuit, and we've got a lot of other examples to explore how it can really be helpful in understanding the dynamics of circuits. In this case, we have a rectifier. You can see the AC signal coming in from the left power source, which corresponds to the actual yellow sine wave at the bottom, of which we can only see the positive side of it actually, but that's just because the oscilloscope wasn't in view. And then you can see the out, which is actually the voltage through the resistor, the load on the right, and you can see that it has been rectified to only the positive sign. And just like this, we can mess around with the values and understand how a change in capacitor and resistor load and an input signal can vary the results. All right, so let's look at one more example and understand how these components work. So here is the operational amplifier, friend to many, I'm sure. So we have a 500 megahertz signal, 1 volt, as you can see over here on the right, going into the non-inverting terminal, and you can see V out. And you can see up in the top right window all the parameters for the op-amp. So we've got 1 millivolt in, or I mean 1,000 millivolts in, which is a volt, and you've got up to 10 volts out. So 1 to 10 gives you a gain of 10, which is what this is producing. And we've got the negative feedback loop down here. And let's go ahead and select this resistor load right here. You can see the amperage and the voltage through that. Okay, so you can mess around with this, change the terminal that the signal is going into. You can change the resistor values. You can change the feedback loops, including the feedback through the negative or through the positive terminals, and get a better understanding of how op-amps work. And here is one last graphic on the oscilloscope showing what's going on here. So we can graph the V out, which oscillates between -9 and 9, or -10 and 10, and then we can graph V in, which is this terminal right here. And there it is. So this is going into the non-inverting terminal, so it is in phase, or it matches with the V out. And this is the way that iCircuit is most useful for understanding what's going on, especially when you get into more delicate projects where you have to keep a much closer watch on voltages and amperages running through different nodes. You don't want to mess things up, or else they're either going to catch fire or they're not going to work at all. So, all right. The last example is the oscillator, and this is really cool to look at in iCircuit because you can actually see the relation between either the cap and the transistors or between both caps. So for example, here I'm going to graph, here's one cap, the one on the left, and I'm going to graph the second one, the one on the right, and you can see how they work in consonance. So as one charges, the other one discharges through the transistor, and vice versa. All right, so this is really intuitive, and that's why I really like iCircuit a lot. Okay, so that was iCircuit, and in the next video, which is going to be the last one for the series, we're going to look at LTSpice and Eagle together. And they combine some of the more professional functionalities of software packages for electronic design. They're a little bit more advanced, but they can still be usable for the novice or apprentice, so I like them just as much. So I'll see you in the next video. And don't forget to like, share, and subscribe. See ya.